Okay, so has anyone turned in the assignment yet? I mean, earlier I didn't see any submissions. So still working on it. So we'll talk about it a little bit, or at least a couple of the problems. And see if you're going in the direction that I'm going in. Okay, so here's a little bit of code, and basically I am using a camera calibration from earlier, right? And then I had run the camera calibrator on the files that from the hallway, but most of them camera calibrator couldn't find the images. Luckily, it did find 2 critical images. So here they are. I think here's one. That's good. Okay, so this is first image that we took. This first. So basically, we're verifying that the data points lie on the checkerboards. And then red is the x-axis or blue axis? Red is the points for which x is 0, so that would be the y-axis. And blue are the points for which y is 0, so that would be the x-axis. Okay. So if we look at the image again, which way does the z-axis go? Downward. So it is in the same direction as the camera axis, right? As in the camera y-axis. Rotation matrix. here's the rotation matrix that came from camera extrinsics. So, we know there's a confusion about which way we're multiplying, and whether we ought to look at a row or a column. So, my first guess was that this is the appropriate axis to look at. But now, since we're talking about the z-axis being in the y direction of the camera, I'm beginning to think that maybe this is the axis we should be looking at. If I look at this axis, I can calculate the angle between this vector and the camera y vector, which would be 0, 1, 0. Okay? And I would do that by taking a cross product between the two. Okay? And then I would calculate the arc sine of the cross product. I know these are unit vectors, so I don't have to worry about that. And that should give me the angle. But based on what we're talking about now, I think I want to change the sign. And use the third row instead of the third column. Difference in values isn't much, so it's hard to tell from this which is the right answer. But it looks like a downward angle of almost 5 degrees. All right? And that makes a little sense because if you look at the image, the camera is looking pretty much down the hallway. All right? After I took those first 2 images, I lowered the camera somewhat. Okay? And we can see that angle. If I go back to the code here. And go over both of these images. So the first couple of pictures look like a downward angle of about 5 degrees. And the second picture, I remember pushing the camera down, so it's looking more downward. Can't see as much of the hall. And that looks like an angle of about 17 degrees. Okay? Now, if we go to the pictures we took, I can take the image and then I'm using G input, however accurate that is. So basically I'm trying to figure out what the vertical axis of the camera is, right? By going up the tripod, and then I'm trying to make an image go down. And this is by eye, so I'm not sure whether that's absolutely precisely right or not. Looking at it now, looks like maybe I need to go down a little bit more, just a shade. But just to give you an idea of the accuracy. Okay, so if we have these two vectors, this vector and that vector, what can we do? We can take the cross product between those two vectors, and we'll assume that the z direction coming out is 0, right? So that do that cross product, and then from the cross product, we can get the angle between it, which is this angle. But probably what I want to do is take that angle and subtract it from 90 degrees in order to get the downward looking angle. So you can see from the code, I took 4 points, one defining the up vector, and then another one defining along the camera, and then constructing the vector from one point to the next, normalizing it to unit magnitude, taking the cross product, and then doing the arc sine, subtracting it from 90. And we get about 15 degrees. So we're in disagreement by about 2 degrees, and given the situation, that's probably as close as I'm going to get, since this is all done by eye. Right? But at least that gives us some confidence that the angle we calculated from the image or from the extrinsics is the same, is the actual angle that we're establishing from our camera measurements. I don't remember which question it was, but that was one of the questions I had, was what is the camera look down angle? So I would expect you to come up with similar answers, but I also suspect they would be a tiny bit different. Files here. Okay, so then this morning I was at home because watching some grandchildren, and at the home computer I don't have the MATLAB computer vision toolbox. I have to use my work computer for that, which is here. All right, so I ended up doing a Bugeaud calibration, which stunk. So in order to get what I wanted, I had to hand select the corners. So they weren't all that great. That's a prelude to things may not work as perfectly as they should be. If I were doing it over, I would repeat it, but I would use the camera calibrator points, which are much better. So at any rate, we're going to take one of the images. This is the first image. And I'm going to read it in. And then I'm going to show the position of the corners, which ended up being selected. Right, so I'll run that section. Let's clear stuff Okay, so there is the first image. And those are the corner points for it. Now, I don't know how carefully we laid out the checkerboard in the hallway, but looking at it here, looks like it was pretty parallel to the tiles, right? So I think that the checkerboard is pretty parallel to the hallway walls, all right? That would have been my guess. Now, is the camera perpendicular to the checkerboard? Not exactly, all right? And how do I know that? Look at the bottom of the picture, okay? That's the bottom part of the camera, all right? And look at the checkerboard relative to it. You see there's not a big angle, but there's a distinct angle between the checkerboard and the bottom part of the camera. So I think that the camera is a few degrees different from looking. It's mostly straight down the hallway, but I think there's a little shear to it. Okay, so those of you using the Peugeot toolbox know that he has this crazy numbering system, right, where he puts an underscore for each of his sets of data. So this is, I'm collecting his data and I'm putting it in, as a separate dimension of the image points, which is kind of the way the camera calibrator works. And then I'm creating a set of world points. It's not doing anything interesting. And then we're going to take the image points and we're going to fit a T-form to them, which is what we're doing right there. And the first thing we're going to do is we're going to just try warping it, just to see what the overall thing is. I'm not doing any change of scales there. So if I run this, it comes out looking that way. Okay. So it's the usual behavior of the hallway shooting out and the walls going off to an angle. This is typical. For some reason, put a lot of black in there. I guess I don't know how MATLAB handled that. So the next step from there is to fool around with the reference parameters and pick something that looks a little better. So that looks a little better, right? And if I've chosen them right, I take a look at the reference parameters that come out, and I want to make sure that the pixel extent in world X is the same as the pixel extent in world Y. That makes it a square, pixels are square. So that's better. And along about here, I decided that I would like to look at some features. Okay, so what I did is I used G input again. Okay, and then acquired some features of interest, and I'll show them to you in a minute. So once they're acquired, I save them out to a .NET file so I don't have to read them in again. And then here I am displaying the 3 separate lines that I took. Okay, so let's run that. So one of the points is along the base of the image. I'm just trying to verify that. I screwed it up a little, all right? If you look here, you can see a tiny little bit of hallway in there, all right? Okay, we're going to see that when we manipulate a little bit later, a little bit of hallway. And then I chose along this part of the hallway, and I chose along that part of the hallway. Right? So those are the 3 images, or the 3 lines in question here. And if you have a set of image points, we've been through this, there's transform points forward, where you specify the transform, you give the image points, and it's going to generate the corresponding map points. Okay, that's the X and Y points. Okay, so then I picked a slightly different view here, and here's a routine right there that we have not talked about yet. I suspect it may have been on some of the code we looked at. I just didn't think to mention it. So I'm going to mention it now because it's very useful. Okay? Remember, transform points forward goes from image points to the T-form points.